Welcome to our lesson on types of cells and Ohm's law. To begin, here is a little puzzle for you. You see an array of letters. There are three words that can be formed if you start at one letter and continue to an adjacent letter until you make a word. There are three of them. Pause if you would like to figure out what the three words are, but for now, we'll move on. So today, we're looking at types of cells and Ohm's law. There are two types of cells, primary and secondary cells. A primary cell, also known as a dry cell, is a battery that is designed to be used once and discarded. In general, the electrochemical reaction occurring in the cell is not reversible, rendering the cell unrechargeable. For the makeup of a cell, let's take a look at this clip from Bill Nye.
Batteries and hot dogs are a lot alike. No kidding. A hot dog has a piece of meat with a roll around it. Well, inside a battery, there's a long rod with a can around it. Now, between the rod and the can is some goopy chemicals called electrolytes. Now, that's what makes electricity flow. Between a hot dog and the roll are some goopy chemicals called mustard and relish. So instead of poles, it has rolls. Now, if you put a hot dog in a flashlight, nothing happens. Duh. That's because a hot dog doesn't have the right chemicals to make electricity flow. But a battery does. And those chemicals are what make electricity flow from one end of the battery to the other. Now, when the chemicals are used up, the electricity stops and the battery's dead. But batteries are a good, compact source of energy. So are hot dogs.
So you are required to be able to know the parts of a cell and to be able to draw it. A secondary cell, also known as a wet cell, is a rechargeable electrical cell that converts chemical energy into electrical energy by a reversible chemical reaction. The most typical example of a wet cell is a car battery. Here we see what inside of a car battery looks like. Secondary cells, unlike primary cells, can be discharged and recharged many hundreds of times. Secondary cells are often referred to as rechargeable batteries. Secondary cells are so named since there are two chemical processes involved, one to discharge the cell and one to charge the cell. A car battery consists of a group of secondary cells. Here, I would like to make the distinction that a single cell is what we commonly think of as a battery, but it is not really a battery. A battery consists of two or more cells. So, why is a primary cell considered a dry cell? Because it contains an electrolyte that is a paste, a dry paste we say. Usually like zinc carbon cells or alkaline cells. Secondary cells are also known as wet cells because they contain an electrolyte that is a liquid, usually a lead acid. Comparing primary cells to secondary cells, it is notable that primary cells have a high internal resistance and therefore produce a small current. Secondary cells are the opposite. Their internal resistance is very low and hence they produce a very large current. Next we come to resistance. The electrical resistance of a circuit component or device is defined as the ratio of the voltage applied to the electric current which flows through it. The unit of resistance is the ohm, and that is your symbol there. It is the Greek letter omega, which we use for ohm in physics to represent resistance. But what does this definition mean? Resistance is how much current you actually get to pass through a circuit based on how much driving force or voltage you apply. Based on that definition, we have then our formula R equals V over I. Here we have a nice little meme, join the resistance. Let's get into an example now. Let's say the current through a filament lamp is 5 amperes and the voltage across it is 20 volts. What is the resistance of the filament lamp? So we identify our givens. Current is 5 amperes, voltage is 20 volts. What's the resistance? Easy enough. R equals V over I. 20 divided by 5 gives us 4 amperes. Now we come to Ohm's law. Ohm's law states that the current flowing through a resistor at a constant temperature is directly proportional to the voltage across the resistor. So for an ohmic conductor, as we see here represented by this graph, the graph is a straight line that passes through the origin because that shows direct proportionality. A filament lamp, on the other hand, is not an ohmic conductor. Our graph here is a curve. What does this curve show? It shows that as the voltage increases, the current maxes out. It doesn't get higher and higher as the voltage gets bigger and bigger. This happens because the filament lamp, also known as a light bulb, gets hot. The hotter a conductor becomes, then the more resistance it has. The reason why your computer logs are usually air conditioned is to keep the temperature low, because as current passes through any conductor, it is going to cause the temperature of that conductor to increase. So your computers, if they were left out in the heat, would start to perform slowly because less current would flow through them as they heated up. So to keep them from heating up, we air condition our computer labs. And the same thing goes for your laptop. Why does it have a cooling fan? To keep the resistance low by keeping the temperature low so that it can obey Ohm's law to provide a nice, smooth, steady current. A copper sulfate solution is also considered an ohmic conductor. How is it that a copper sulfate solution can be an ohmic conductor? Well, a copper sulfate solution has water, a key element that helps to keep the temperature low. We all know that water is used to combat heat. So when the voltage increases and the current also increases, it does not heat up the copper sulfate solution to the point where resistance increases. And that is all for today.